Hey everyone, this is Calvin, and welcome to the HackFS 2024 workshop titled How to Build On-Chain AI Agents on Galadriel. Joining us today is Karl, who will be taking us through this session. And with that, I'll pass it over to Karl to get the workshop started.
Thank you so much. My name is Karl. I'm really glad to be part of HackFS, and in general the ETH Global developer ecosystem, and represent Galadriel. Um, I'm the head of growth here at Galadriel, but I love working with developers, and I am originally a developer myself. So I'm now transitioned more into helping the army of Web3 developers to onboard into building on-chain AI. And I have prepared a few slides for you today and a workshop on how to build on-chain AI agents with Galadriel. And before we start, if anything, my goal today will be to inspire you to experiment and build decentralized AI applications on chain, as we see this being the next frontier in tech. And I'm really proud to be here to show you how this can be done with Galadriel. So without further ado, Galadriel is the first layer one blockchain for AI. And what this means is we enable developers to essentially build decentralized and on-chain AI applications and agents through smart contracts. So just the same way as you can build on any EVM chain or ETH itself, any general purpose decentralized applications, we want to do the same or enable the same for developers to do. And all of this is enabled by our latest flagship product, which we have called teeML. And teeML is kind of the backbone that enables getting these state-of-the-art AI models, whether they're open source or closed source, getting the inference of these AI models on chain in a low latency, low cost, and verifiable manner. We have built this really easy to use playground for everyone to go and, before they start building, actually try it out themselves, use it themselves. Here you can see that it's fully open source. You can also go and read the code. You can try it out here by just putting in your prompt and hitting generate. It will prompt you with a MetaMask. I don't know if you can actually see this right now. But if you can't, then I need to confirm an on-chain transaction for it to work. And in the background, what is happening is explained here. And before we start building, I will actually just quickly go through what is happening actually in the background. How do we get the AI inference on chain? So similar to this page here, we have deployed an AI contract on chain. So let it be our T app. Oh, you could already see the response. We'll get to that later. But let's say we want to build our own on-chain agent or on-chain AI application. And for that, we will need to build a contract first for it, which we will do later. And the contract that we'll deploy and build needs to interact with an AI Oracle contract that we have deployed on chain already for you. You can do it yourself, but it's essentially a two-part system. One part of the Oracle lives on chain, and the other part is off chain, which lives inside the teeML that enables all this to happen. And teeML by itself is a trusted execution environment that generates an attestation when it starts up, and we basically push this attestation on chain to make the whole system verifiable we also have tutorials for developers who want to dive deep into how to verify the inference or that attestation. But I'm not going to show this here in this workshop. So just to know that it's also open source and we have the tutorials in our GitHub. Now, if we want to build an AI app on chain, we need to, as I said before, interact with the Oracle, and we send to the Oracle. For example, if we are using GPT-4, we need to tell the AI Oracle that we want to use GPT-4 and what is the prompt or the text input that we want to send to this AI model. Now, this Oracle forwards the message to the off-chain teeML, and inside the teeML we have the AI backend, so to say, running, which does the actual inference to the AI model itself. Whether it is an open source model running directly in the trusted execution environment, or it does an API call to a closed, AI model that lives in someone else's server. And then if it gets back the inference result, it pushes it to the AI Oracle contract, which in turn then returns the inference callback result to our application contract, which you saw happening here. And if you're using this teeML playground, you can obviously go and use Galadriel Explorer to actually see what happened under the hood and what gets stored on chain and what happened on chain using the transaction hash. Yeah, now let's see it all in code and try to build one ourselves in this workshop. And I thought about building doing a tutorial on how to build a really how to say, on-chain agent, which is a little bit more advanced than just bringing the LLM inference on-chain. And my idea was that why don't we start with something simple, more simpler, just to lay down the groundwork from where you can kind of take what we do here, and with a few tweaks, you can make this simple on-chain LLM kind of chatbot into an agent. And I will later on give you a good explanation of what's the difference between just a simple LLM chat on chain and what makes an agent. But before we get there, I think it's better if we start from the simple stuff to enable you onboard more quicker, and then from there you can take it and tweak it into an agent, which is a little bit more advanced, but we have tutorials on that as well. And before we start, I'm going to just show the example application that we have built already. It's also open source. You can see if you go to our GitHub, you can see it in the examples folder. This is what we're going to build today, essentially, without the front end side of it, but backend or contract in Web3 world. And this is basically the same thing if you go to OpenAI's, ChatGPT, but this is built using Galadriel, and the AI is brought on chain. Takes a little bit of time because it has to go through the whole flow that I just showed you on the teeML website. And here you can see the response, and you can also go and check out the transaction was successful on chain. And now to the workshop, to actually building the chatbot ourselves or building the LLM inference on chain. I will be using our own tutorial that we have written in our documentation. So if you're watching this as a recording, not live, you can simply take our docs in front of you, in front of the video, and kind of go through the whole thing with me if you cannot do it right now live. And I'm going to be using Remix because just for the convenience, I have it all here in my browser. But whatever toolset you're used to, Hardhat, etc., or like DevNet, Galadriel DevNet is like supported on all of them. So there shouldn't be an issue if you have a different kind of a toolset. Yeah, so we're gonna build an on-chain ChatGPT like chatbot. We're going to bring the AI inference on chain. And as a prerequisite, you do need to set up your own wallet, which I'm not going to show you how to do right now, just to keep us on track with time. But it's really easy. It takes just a minute. Any like EVM wallet is fine. I'm using MetaMask myself. And you also need Galadriel DevNet tokens. Because Galadriel is a layer 1 blockchain, we need tokens to pay for the transactions. We need tokens to pay for the gas, essentially. And for this, you need to use our faucet, which right now is available in our Discord. It has also, if you click here, you'll see the tutorial. It takes just a minute to get DevNet tokens. And now, without further ado, let's start building the contract. I did already set up the base for the contract, so I had the constructor here, the contract, etc. And next, what we need to do is kind of a basic thing, but we need to define the owner or the message sender, who will be the one who deploys the contract, and the Oracle address, which I showed you here already. I'm just going to take it next here to show you the visuals. So we need to define the contract address for this AI Oracle, because if we want to use our AI app, we need to call out the AI Oracle. So let's put this in the constructor. Swap this out here. And these will be used both here in the next functions, which are kind of like helper functions, but these are like modifiers that basically protect the functions so that not anyone can call out. So that not anyone can call out these functions. So they're not publicly accessible for anyone, but we can use the only owner modifier to call out, for example, the set Oracle address. If we want to later edit the Oracle, if the Oracle address has been updated, you need to also edit it here in the contract. So let us get these functions here in the contract. Oops. And I'll also show you later where we are using the only Oracle modifier. So only that AI contract Oracle can call out functions in our contract. And I'm not going to go too deep into this, but you can also go and read how the Oracle itself works, because the Oracle is kind of part of the teeML solution that I talked about later, and this is the core kind of design how we get the AI inference on chain by using this Oracle. Here you also see like an image how the transaction flows through the whole system. So this is all like the on-chain part of the Oracle, and this is the teeML that is running off-chain that does the actual AI inference and then pushes the result back on chain to your AI application contract. Where were we? Here. Now we need to define the Oracle interface, because in our contract, we need to define what are the functions that we are calling out on AI oracle. So here you can like see already that create LLM call is one function, which we're going to use here to get the inference from the AI oracle contract. And now the kind of core logic to actually start the chat with the LLM. What are the functions that we need, and what are the like data structures that we need to define in our contract in order to get this functionality. And to do basic ones, we need to define our message and chat run. So message is something that kind of defines the structure for an incoming and outgoing message to the AI chatbot or the LLM. And you will later see this used inside the chat functions that we're going to use. And the chat run struct is a storage, basically, where we need to store the chat history. So you can think of it having like, you can start more than one chat with the LLM, and all of them have their own chat history. So in, let's say chat ID 1, you will have your text messages with your chatbot, which are totally unrelated to the chat ID chat history messages. So it enables you to build this kind of storage system where you can store these like chat histories and give it more like a chatbot feel. Let's define these in the beginning. And the role and content here, role is if I'm sending a text to the LLM, then the role is usually user. And if I get a response back from the LLM, then the role is defined as assistant. So this is kind of basic working with large language models or LLMs, how the messages are structured. Now, next we need to define a function to start the chat itself. And as I told you earlier, you can start more than one chat. This is why we have it as a separate function. So you need to first start the chat, initiate the chat, and then you can start adding messages on top of the chat. So you can think of it like stacking the chat history for each chat. And here you can see we're using the same message struct that we used, and we are like defining that it's the user who sends the message, who initiates the chat itself. And in the end, we are using the create LLM call function that we defined in the interface above. And as an input, we are not giving it like the message content itself, but we are creating an ID and giving it the ID, because we are storing all the messages in our contract. We don't want to send the content out of our like AI contract. We want all the application related data to be inside our own contract. So let's copy this and paste this here. So remember, this is to start the chat. And now we need to add the functionality to stack messages if we want to on top of the chat. So we create this kind of a chat history. The LLM has, a knowledge of what we spoke about earlier. So if I say, hello, my name is Karl, AI is like, hey, how can I assist you? And I can ask it, what's my name? And based on the chat history, it has actual like knowledge about who I am. if we didn't use the chat history, which you can also do here, just a simpler version of what we're doing right now, then you won't be able to reference back to the messages that you sent earlier. But we want to add this right now. And now we need a few functions to actually show the response from the LLM call that we did. And for this, we need get message history contents and get message history roles. You can retrieve the roles and message history separately from these functions. It could be built into a one key value list as well, so you could retrieve it as one with a one function. But we haven't we haven't done the refactoring for it, but essentially it is possible. So need these functions to get the content. You can see here the message history and the roles, and if you map them together, you will know who sent what message. This is the whole point of this. And now final function, which I mentioned you earlier, that the AI oracle here needs to call out a function in our contract to return the result from the AI or the LLM. And for this, we need to define a callback function in our own Discord. And you can see here that the role of the message that we'll store in our contract is going to be assistant. So we know that this is sent by the LLM. Let's define this in here. And now we have all the logic in place in our smart contract. Let's see if it compiles. It should compile. Yep, everything worked. And sorry, it's the old one. Like I mentioned you earlier, we need to, on the deployment, we need to define what's the address of the AI Oracle contract here. And this you can find also in our docs. We have a link here somewhere. There we go. Galadriel provided Oracle. Can use the first one. This is connected to the teeML that I showed you and running on our DevNet. We update this every time we redeploy the contract. And now if we deploy it, MetaMask pops up, wants me to confirm the transaction, pay for the gas. It was successful. And now we can start using it. So first, as I already told you, we need to start the chat before we start adding messages or actually reading the contents of it. And we can start with what is up. We need to confirm the transaction again in our MetaMask. Let's click confirm. Now you can already see that the initial transaction was successful. What is happening in the background is that the AI contract is now talking to the off-chain teeML. The off-chain teeML is running an inference on the AI model itself, on the LLM itself, and then returning the result back to the AI Oracle, contract here, which uses the callback function that we defined as a last part of our contract to actually retrieve the result back to our application contract. So all this happened in meanwhile while I was talking. And you can see the chat ID here is 0, and we need to use the chat ID to retrieve each chat content, basically. Yeah, because like I mentioned earlier, you can start more than one chat based on this contract. So get message history, get message history content. We need to use this one. The chat ID is 0 equals 0, and hopefully there it is. So this is like a list separated by a comma, and the content that I sent to the AI LLM model is what's up, what is up, and the response back is as a language model developed by OpenAI, blah, 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 blah. So what we did is we called out an off-chain trusted execution environment that is verifiable because we post the attestation on chain, but in a low latency manner, got a result back from the state-of-the-art LLM that we have available right now for developers to use. It's pretty incredible tool to actually experiment with and build these, AI-enabled contracts on chain. And yeah, this is it for the code part. I hope this was helpful. I have a few more slides before I finish. And what would make this that I showed you an agent would be if the LLM would run in a loop. So what I did right now was I sent an input and I got back an output. So this is like ping pong, ping pong. I send, I get back. But when I want to build an agent, I want it to be like autonomous. And what makes it autonomous is if I, for example, give it a task. And in this example here, you can see I'm asking it, hey, what's the weather in London? And I give it the task, and what I want back is the result for the task, or like a completed task. And how does an LLM do that? How does it know what's the weather in London right now? It doesn't have real-time data, does it? Because it's trained on a certain amount of data. But what makes a simple chatbot agentic or adds agent-like features is enabling it with tools. So this is something that you can also do with Galadriel, because if you go to our docs, you can read what tools do we support. For example, Google search. You can give the AI capability to go and search some results from Google, for example. And once it gets back the results, it is able to then tell you the real-time data that you asked for it. So in this case, the LLM is prompted by the developer to go and use a tool if it doesn't know the answer. Then it goes and Googles it. It gets the London weather and then returns the response to me. And all this happens in a loop. So it's not just you call it out once and you get the response back at the same second, but it's actually like running in a loop, doing several LLM calls, kind of like thinking in a sense. So first it might output, I don't know the answer because I don't have the data. Then it runs the second loop, then it knows, oh, but I don't know the data, but I can use a tool. Then it runs the third loop to kind of formulate the answer for you. And maybe the fourth one is saying, here's your answer. This is the weather in London. If my explanation was a little bit too kind of hard to understand and broad, then we have listed out a few like Web 2 versions of AI agents that we as a team have been experimenting with and kind of think are the cutting edge of AI agents, which you can see here. I'm not going to go through all of them, but you can find them here on the slides and also in our the description of our challenge that we have for HackFS. And we also have a tutorial in our docs explaining how you can take this simple chatbot calling an LLM example, what we just built, and tweak it a little bit to turn it into an actual agent. Yes. And I guess that's it from me. I will leave you with saying that we also would encourage developers to join our Galadriel Discord because we always showcase the projects that you've built, and we incentivize you to share your knowledge and the projects, and we'll reward you with points. Basically, as we're rolling out a point system, we want to incentivize the developers to build on Galadriel DevNet, and encourage you to join Galadriel Discord as well. Thank you.
Perfect. Thank you, Karl, for joining us today and for the great presentation. If there are any questions, feel free to unmute yourself and shoot your questions on the chat box.
If you don't have any questions right now, I'm also, the whole team is, Galadriel team is available at ETH Global Discord. We have our partner, chat partner Galadriel, where you can simply, ping us. We will check it every day of the hackathon. Or as I said, come join our Discord. We're all online as we're teachers ourselves, so we'll be checking out these channels.
So, Karl, looks like we have a question from Bharatraj. Do you want to take that up? It's in the chat box.
Yes. How does RAG work? Are you maintaining running a vector database connected to the Oracle? So I will send the tutorial here, the link to the RAG tutorial. But yes, we are maintaining it ourselves. This is the same reason why we kind of deployed our own AI Oracle contract for developers to use. This is possible for you if you want to. You can add like your own models. You can add whatever kind of service you want. But it's not just the on-chain part that you need to deploy. You also need to deploy the off-chain teeML part, and this is usually a lot more time-consuming and kind of it's more expensive to do. This is why we have done it for developers. And the same thing goes with the RAG. If there's any kind of database service or an LLM service that you'd be interested in us running, then you can simply let us know. Or if you're like a hardcore developer, then you can obviously deploy these contracts yourself and run the teeML yourself, because all of the code is open source in our GitHub. And you can see all of the services that we have actually from the Oracle contract itself, which is also in our GitHub. Let me just pull it up and send you all of the functions that you can basically call out in if you're building an AI contract yourself, and you want to know what are the services or like what can I use to build the AI contract, then you simply can check out from the Oracle code here what are the requests that you can do. And I think RAG is named as knowledge base query.
Perfect. Any more questions for Karl before we close in the next 1 minute?
I'll also share the link to slides if anyone wants to click on the links that I showed. Oh, sorry, I need to provide access. Anyone with the link can view. Okay, now you should be able to access the slides.
Great. You can also post this on Discord so that anyone can access it, whoever is not joined the call today. So
Yes,
yeah,
absolutely.
awesome. Yeah. That being said, thank you everyone for joining the workshop. Feel free to connect with Karl, as he mentioned in the partner channel on Discord, if you have any question, and anyone from the Gadriel team shall get back to you. So thanks again, and cheers. Bye-bye.
Bye.